So in this video we're going to find the general formulas for the skewness and kurtosis of a standard distribution. Now we're looking for the specific distribution in this case. If you check the link below, you'll see somewhere we calculate specific distributions where we get skewness and kurtosis. This one here we're looking for the general formula. So as we're looking for the general formula, the place to start is the standard score function. So the standard score function is x minus population mean divided by the standard deviation for that population. That's our score function. Now we use this to find the standard formulas for skewness and kurtosis. So if you start with skewness, so the skew of a random variable x, the way we do that is we find the expectation of this score function cubed. So that's where we start from. So then we've got x minus population mean divided by standard deviation cubed and expectation of all of that. So first things we need to do here is to expand this score function cubed. So let's go with that on this next line. So now we want the expectation. Now let's cube this. So our denominator will leave the standard deviation cubed. Obviously if we're cubing this, that's not going to change. And now we need to expand our numerator when it's cubed. Now we use the binomial expansion, we'll end up with x cubed minus 3x squared mu plus 3x mu squared minus mu cubed. So that's what we'll get when we expand that out. Okay, now where do we go from there? Well, next thing we need to do is to use the linearity of expectation. Now if you check the link below, I'll show some videos how we explain that. But here we've got expectation of our random variables, so we can separate them all out and find the expectation of those all separately. So now we're left with the expectation of x cubed. So we're only dealing with the denominator here. So only dealing with the numerator here. Our denominator will stay as sigma cubed. So that's not going to change with the expectation. So e of x cubed. Next we've got the expectation of 3x squared mu. So for this we'll write minus 3 times the expectation of x squared times mu. And then similarly for this one, expectation of our random variable. So we've got plus 3 times the expectation of x times the population mean squared. And here we've got mu cubed. So we just leave that as mu cubed. Okay, so that takes care of that. Now we need some identities to try and simplify this off a little bit more. So we've got e of x, that's our expectation of our random variable. That's just the same as our population mean. And e of x squared, we can expand out on that a little bit. E of x squared, we can put that as mu squared plus sigma squared. So that would take care of that. So now let's substitute all those into this and see if we can simplify it off some more. So expectation of x cubed, that's going to have to stay. So that's not the same as the mean cubed, that's expectation of x cubed, so that's the third moment. Here we've got 3 times e of x squared times mu. Well, e of x squared we've got here. So we've got minus 3 times mu squared plus sigma squared times mu. That takes care of this one. Now this one we've got e of x, which is mu. So 3 times mu squared, that will just simply be plus 3 mu cubed. So that takes care of that. And here we've got minus mu cubed. Okay, and then our sigma cubed stays on our denominator. Okay, now we can simplify this up even more. So our third moment will stay. Now let's simplify this up. We've got minus 3 mu squared times mu, so that's going to give us minus 3 mu cubed. And we've got 3 well, minus 3 times sigma squared mu. So that can stay like that. So that completes that term. Here we've got plus 3 mu cubed minus mu cubed. So that's just going to give us 2 mu cubed, as in positive. Okay, and then we can just divide all that by sigma cubed. Okay, now we can break this right down. We've got minus 3 mu cubed plus 2 mu cubed. So that's just going to give us minus mu cubed. And this one here, there's nothing else we can do with that. So this then equals expectation of x cubed minus mu cubed and minus 3 sigma squared mu divided by sigma cubed. And that would take care of our skewness for x. Okay, so now that's finished. What we can do is now clear the board and we'll try and calculate our kurtosis. Okay, so now we'll calculate the kurtosis. So it's very similar to the skewness, except for the power that we raise the z-score to. So the kurtosis of x is the expectation as before. Now this time our z-score is raised to the 4th power. So now we've got x minus population mean, standard deviation mean to the power of 4. Okay, so now this time we need to expand this out to the power of 4. Okay, so let's take care of that. So then this equals expectation. So sigma will be to the power of 4. That can stay on our denominator. And then we'll have x to the power of 4. So that will stay there. And then this time we'll have minus 4 x cubed mu. And then using binomial expansion, we'll have plus 6 x squared mu squared. And then minus 4 mu cubed and x. And then at the end plus mu to the power of 4. So that will take care of all of that. Okay, so now let's use linearity of expectation like we did in the last one and use some of these to simplify off. So now we've got expectation of x to the 4. That's this one. Okay, this time we've got minus 4 times x cubed. So that's minus 4 times expectation of x cubed and multiplied by mu. This time we've got 6 times e of x squared, and that's going to be multiplied by mu squared. And we've got 4 times e of x mu cubed. Well, e of x, let's go straight in there with our mu. So that's 4 times mu to the 4. And then we've got plus mu to the 4. So that's going to give us minus 3 mu to the 4 with these two terms. So that would take care of that one straight away. And then we can divide this by sigma to the power of 4. So, okay, let me just write these ones up here just to show what we got for this. So minus 4 times x is mu times mu squared, cubed, and then plus mu to the 4. So that's how we got minus 3 mu to the 4. Okay, now e of x squared is mu squared plus sigma squared. So let's put that in that place. So now we've got expectation of x to the 4 minus 4 e of x cubed mu. So nothing we can do with this one. But this one, I can substitute that one in there. So we've got plus 6 times mu squared plus sigma squared times mu squared, and then minus 3 mu to the 4. Okay, now we can see here we're going to have a mu to the 4 here to go along with this one. So it's looking good, we've got more simplifications coming. So then I'm going to write here now my kurtosis of our random variable x. So expectation of x to the 4. This one we can't do anymore So minus 4 times expectation of x cubed times mu. Okay, let's expand this one out and let's see if we can go straight in with this one. So we've got plus 6 mu squared times mu squared. So we've got plus 6 mu to the 4 and minus 3 mu to the 4. So then we're going to left with plus 3 mu to the 4. So that would take care of that. And now with the sigma squared, so 6 sigma squared mu squared, and that would take care of that. Okay, and then not forgetting to divide by sigma to the power of 4. Okay, so that is then no more simplification possible on that. That's going to be our kurtosis general formula. So I'll leave that in a box there. So there we go. That's our kurtosis and that's our Skewness general formulas. Okay.